Okay, multiple integral 1. The topic is multiple integral of 1. So definition of integrals. The concept of integral, the concept of integral, integration a to b f of x dx is equation 1 is physically the area under a curve y is equal to f of x. Say the x-axis. And the two ordinates x equal to a and x is equal to b. It is defined as the limit of the sum. So for example, this is the x-axis, this is the y-axis. So x equal to a, the line is parallel to y-axis. This is the x is equal to a, the line is parallel to y-axis. X equal to b, the line is parallel to y-axis. So this is called x-axis, 0, y-axis. This is equal, x is equal to a straight line, x equal to b straight line. Y equal to f of x is the curve. So the curve, maybe this one, curve. Y equal to f of x is curve. Okay, this part is called, this part, area. This is part is considered area. Okay, this part is considered area. Okay, this is the meaning. Okay, so f of x1 is written as f of limit of the sum, f of x1. So first of all, integration f of x1 delta x1 plus integration f of x2 delta x2 plus and so on, integration f of xn delta xn. So apply the both limit when n tends to infinity and so on, n tends to infinity, and each of the length, this is the limit n tends to infinity, that is the meaning. Each of the limit length so delta x1 comma delta x2 and so on delta xn tends to 0 xn tends to 0 here delta x1 delta x2 and so on delta xn are n subdivisions small n subdivisions into which the range of integration has been divided and write down continue next step and write down and x1 comma x2 and so on xn are the values of x lying respectively in the first, second and so on nth sub okay the formulas what are some formulas integration formula so integration 1 dx that is the value x integration dx x integration x dx x square by 2 integration x square dx x cube by 3 integration x power n dx x power n plus 1 by n plus 1 plus c integration 1 by x dx log x integration log x dx x into log x minus 1 plus c integration root x dx 2 by 3 x power 3 by 2 plus c integration 1 by root x dx so 1 by 2 root x plus c 2 root x plus c 2 root x plus c
In progress.
root x plus c. Integration a power x dx a power x by log a. Integration e power x dx, e power x plus c. So this is the most important formulas. Next, trigonometric formulas. Integration sin x dx minus cos x. Integration cos x dx sin x plus c. Integration tan x dx log of secant x plus c. Integration cot x dx log of sin x plus c. Okay, right. Continue next step. Integration secant x dx log of secant x plus tan x plus c. Integration cosecant x dx log of cosecant x minus cot x plus c. So very important. Integration secant square x dx tan x plus c. Integration cosecant square x dx minus cot x plus c. Okay, next integration 1 by root of 1 minus x square, inverse trigonometric function, sin inverse x. So very most important, 1 by 1 plus x square dx tan inverse x. Okay, very important. Remaining write down. So this is the important formulas. So double integral. A double integral is the counter part of the above definition. Into let of x comma y be a single valued function of two independent variables x and y defined in a closed region capital A in xy plane. So please observe the diagram. XY plane means graph. A double integration is counterpart of the above definition in two dimensions. F of x comma y is single valued and bounded function. So this is represent area. One consider this is the area, this is the area, and single valued, and taking the delta a part, some part. So two independent variables. So two dimensions. So this area is find out. So this whole part now. So f of x1 y1 delta a1 plus f of x2 comma y2 delta a2 and so on, f of xn yn delta an. So this is right as summation r is equal to 1 to n f of xr comma yr delta ar, equation 2. So then the limit of the sum, equation 2, it exceeds as n tends to infinity, and each and sub-elementary area approaches to 0 in termed as double integral of f of x over the region A and expressed as so denoted by double integration. Simply is find out area, simply denoted area f of x comma y delta a or dA, simply got dA. Area is finally find out. Okay, thus write down, continue next step. So thus double integration A, so double integration means simply find out area f of x comma y dA or delta A, limit n tends to infinity f of xr comma yr delta AR equal number 3. N tends to infinity means delta AR tends to 0. నెక్స్ట్ ఎలా ఎవాల్యుయేట్ చేయాలి, ఎవాల్యుయేటివ్ డబుల్ ఇంటిగ్రల్ evaluation of double integral double integral so double integral or f of x comma y dx dy is discussed under the following three possible cases. So case 1, when the region capital R, please observe how to evaluation. When the region capital R in bounded by two continuous curve y is equal psi of x, that means psi of x, two curves, and y is equal pi of x, two curves, and the limits means coordinates, x coordinate or y coordinates. X is equal to a coordinate and x is equal to b, that means limits also. In such a case, integration is first performed. Integration is first performed with respect to keeping with respect to keeping so y keeping x constant, y keeping y అంటే y వేరియబుల్ తీసుకుంటే x అనేది కాన్స్టెంట్, x యాజ్ ఏ కాన్స్టెంట్, y keeping x as a constant, treat as constant, and then resulting integral is integrand within the limits x is equal to a and x is equal to b. Write down. Next, draw the diagram. Okay, draw the diagram. So this is the x-axis.
Recording stopped. In progress.
Recording stopped. In
So
progress.
please observe, this is the x-axis, y-axis. This is two curves, x equal to a, one line, x equal to b. Two curves is here. So one rectangle region is formed, a, b, c, d. So when the region capital R, this is a region, capital R is bounded by two continuous curves, y equal to psi of x and y equal to pi of x. The limits x equal to a, and in such case integration is first performed with the to y keeping. So first, so what is the integrand? First keeping. So this is a find out one rectangle. So PQ. So find, this is the area. First find out this area and next find out this area. So mathematically expressed as so double integration or f of x comma y dx dy is equal. So first integration, x is equal to a, x is equal to b, and next integration y is equal curve pi of x, psi of x, y equal to psi of x. First y keeping, that means f of x comma y dy, and next to find out the integration dx. First treat as this one and next time treat as again dx. Okay, this is a definite integrals. Write down. Next case 2. Next case 2 problem.
Recording in progress.
Recording in progress.
Same. The first region capital R. Please observe the diagram. First region capital R is bounded by two continuous curve. Please observe the curve. Continuous curve. So x equal to, curves are not y equal to, x equal to pi of y and x equal to psi of y, and the two lines abscissa. Abscissa means parallel to x axis, y equal to a and y is equal to b. So y equal to a is parallel to x axis, y equal to b is parallel to y axis. In such case, integration is first. Integration is first performed with respect to x. First performed x, keeping y as a constant, and then the resulting integral is mathematically expressed as double integration or f of x comma y dx dy is equal integration x is equal to, not y is equal, x equal to pi of y and x equal to psi of y. So integration, so next is consider y is equal to a and b, f of x comma y dx, first perform dx and next perform dy. Okay, so is write as different terms, no problem. First integration write as y is equal to a to b integration x is equal to pi of y, x equal to psi of y. First we have evaluate x integration, y is a constant. So diagram, x-axis and y-axis. So draw x y is equal to a is parallel to x-axis, y is equal to b also parallel to x-axis. So two curves, this is one curve, this is another curve. This is x equal to pi of y, x equal to psi of y. This is x is equal or y is equal to, sorry, y is equal to b, y is equal to a. This is two straight lines. So one rectangle region is find out, a b c d is find out. So between the area PQ, so this part is find out. And then this part is find out. Next, so generally the process is shown in the figure. where the integration carried where the integration is carried out from inner rectangle. Next, last one. Case 3. Write down case 3. When the both pairs of limits are constant, some S, the region of the region of integration is the rectangle ABCD. So draw the diagram. X, Y curve. First x equal to, so region. First x equal to A straight line and x equal to B straight line. Next y is equal to A and y is equal to B straight lines. Draw the first these two straight lines. So all are intersect and the region is find out. This part region and this part region. Finally this part is find out. Final A, B, C, D. P, Q, R, S. In this case, it is immediately whether f of x comma y is integrand first with respect to x or y, anyone, you choose anyone. The result is an altweight in both the cases. So both cases are same. Next, properties. Double integral. properties of double integral are similar to those of definite integral. Let f and g be two continuous and single valued functions of x and y. Within the region capital R, then the first one, integration or f plus h f plus g dx dy. I will write first of all double integral f dx dy plus double integral g dx dy. Okay, write down. Next formula. Second one, double integral or k is the constant, k f dx dy. K is the constant, double integral of or f dx dy, where k is constant. Third one, double integral or f dx dy, integral of r1 f dx dy plus double integral of r2 f dx dy, where r is the disjoint set of where capital R is disjoint union of R1 and R2. So region integration, next topic, region of integration. If the region of integration is a rectangle between the lines x equal to a, x equal to b, y is equal to c and y is equal to d, then double integration or f of x comma y dA is equal integration a to b integration c to d f of x comma y capital no problem dx dy is equal to integration c to d integration a to d f of x comma y dy dx. So this is also case 3 method. Okay, so both are constant, limits are constant, integration with respect to x or with respect to y. So go into problems.
Recording